So, hello everyone, welcome to my video. This time I am come up with another project called Cloud and Supervised ML based Customer Churn Analytics. As you can see on your presentation window. Okay, just let me magnify it. Okay, so this time we will be covering churn report for the telecom data that I made earlier with bagging model and which was effective among other models at that time. So this time this is very short and effective video. Let's move to next slide. Okay, so this time rather than loading from local machine, we will generate reports from cloud itself, and the code is deployed there, and we will make predictions on the new data, and we will generate the reports accordingly. So you can see in presentation window that what features are now in this model, this project, that churn report generation via cloud premises. It means the reports will be generated through cloud, and then ML code modification customized for user client. And this is among these bullets that firstly is used ensemble technique stacking with 99% training and 99% testing score. So I have gone ahead and fine tuned the stacking model, and stacking have proved that it's the best model among others, because what it did, it takes the base model. You can take three base models and a final model, and it improved performance. And basic thing, important thing is that it avoids overfitting. And what is the best thing that I have found, that it is giving the approximate results nearby to the actual data. So what was the actual count of the customer who left the network, I mean churn out of the network. So it is very very much close to that. So that's why the 99% training and testing accuracy is there. And it is a ensemble technique, and among bagging and boosting. But rather than bagging and boosting, it have produced a much better result. So quickly we will see ML based prediction on new data for customer churn. Okay, so that I have already explained. We will do from cloud itself. Easy and effective automation via graphical user interface. So what I have done, I have made a graphical interface over there. Very simple graphical interface. We will give access to the end user or client to go to the cloud premises, because we have designed virtual machine exclusively for them, and there are so many applications among others. So this is one of the application. I mean, graphical user interface. They have to just click and upload their file and give their email address, and they will get the reports. So last point is self report generation via email for user client. So okay, I have explained all these features. Now we will quickly go towards the production part. Okay, so here we are in Azure portal. So like last time, as in project of cloud and AI based FM system, we will just go to the storage accounts where the end user or client can upload their files. Like if we have enabled network drive for them, like this, then they can browse and upload their files, whatever files they want to make predictions. So can they can go and they can upload. So simply they can click on upload button, and they can browse for their files for in local machine. Like if they have some file like df norm, they can upload from here. Okay, so that's all from here. Now we will move to the cloud premises. Okay, so as I told you, we will move to the cloud premises. I'm just opening the remote desktop connection to connect to the cloud, and then we'll do the things over there in production server of cloud. Okay, so here we are in cloud. We have logged in through the remote desktop, and now as I told you that our codes are deployed. So I will first show you that we have uploaded the file from there, so it should be here. If we can go here, you can see here, this is the same network drive. Let me show you. This is the same network drive that we have put like this, the Akhil Singh Rawat. And if I click this, this is our file df now. So okay, so what we will do now, I will show you firstly what stacking is doing. And I've already explained. Let me show you, as I told you in ppt also, it has produced and is producing 90%, 99% training and 99% testing score. Okay, let's check here. I have given that file path over here only, and we will run this code, machine learning code, and to understand what stacking is doing. Okay, let's run this. Okay, see what happened is, you can see here what is the training data accuracy. It's here only 99%. What is testing data accuracy? It is here only, it is 99%. So uh, yeah, even I will explain you a little bit, for the technical and non-technical audience both. What stacking does is, I told you that it took base models, like we have took three base models, like you can take a random forest or decision tree or whatever model you like, and as base models, and then use their predictions as input for final model. Here meta model is representing as final model. So the beautiful thing is, for stacking is, the stacking is useful where each base model can learn some part of the problem. Okay, so these three models, base models, are learning some part of the problem but not the whole space of the problem. Understand? Means that, there is some business problem. So model 1, model 2, model 3 have learned and make some predictions understanding some part of the problem. Okay, now what meta model will do, it will combine their predictions as input, and then make a bigger picture out of that. Send some three investigator to investigate something, and they all come up with their story. So now I have three versions. Now I can visualize the bigger picture, and now I will come to know that what's happening. So that's all. That's it. So that, accuracy will increase, and performance will also increase. And but the main thing is to avoid overfitting. So I think it's enough. Now you got it, and you understand you all. So let's move further to the cloud itself. Okay, and you can see, I have already, the last time I showed you, the code is generating, medium, low, medium, high, three reports are making. But you can see what stacking is done is, stacking has divided into two class only, low and high. There is no medium class. So yeah, the predictions that are from the base models are, in the final model, are taken very very effectively. So that we have majority of predictions for the major class. Means whatever the higher accuracy and higher percentage. So I can show you that this is the last time, we ran this. So the actual data of that telecom company, in that data 483 people churned out, and our model has, it 462 it has predicted. But this figure goes little bit up and down these numbers whenever we have to run the code again and again. So we will see what is the that numbers now. Okay, so let's move to the production part. And you know what beautiful thing is then? Oh wow, what a beauty! I have already made a GUI, simple GUI that I told you that the user had to click like this only, like we did for all the application in our laptop or desktop. So a GUI will pop up like this only, customer churn report. And what they have to do is just the upload that file that is only all right. I mean available in the network drive. So if we go to network drive, this one, and this is our df norm is our data file. Just we have to click to upload this. Okay, wow, what a beauty. It is asking and recipient's email address. That is some coding I have done to for client or end user to just come to the cloud and upload your file. Already you have already uploaded your file, and just click on upload button and just put your email address like this and hit the OK button. So soon the code will run. ML code is running behind, and it is making prediction, and you can see the email sent successfully on video. Wow, what a beauty! So this is the power of cloud. This is cloud computing. We don't have to use our resources. And even if I close this from now, it will keep running. You can see here your remote session will be disconnected, but what programs on the remote computer will continue to run after you have disconnected. So this is cloud computing. We are using Azure cloud services, and we don't have to do anything. The application servers are running over there. Okay, so let me go to the that window, email window, and we'll see what are, oh wow, everybody, yeah, I've just refreshed and you can see the fresh mails. So customer churn report high. I already told you that stacking is a for this business problem, stacking is giving higher results. You can see here the count of mobile number for this level high is 4,444. So 444 in more than 90. You can see the index is there. This is another automation I have done, that there are some indexes that how much is in 99% and 98 and 96, how many counts are there. Similarly, you can see that 444 count is there for high. And I even open this CSV file. Okay, let me download and open this. Yes, we are. I'm downloading, and it is all live now. I'm downloading it, yeah, and just opening it in front of the recording. So you can see, oh wow, what a beauty. So this time, this is stacking, which have done the prediction for us, and you can see here every two classes are there over 90. It has taken the prediction from base models and made only the high and low report. So over 90, as I have given the threshold, that put if there is a cases over 90, put in high. So already it has generated high only, and the count is 444 as we got in our email body. We will just check. Okay, let's check. Yeah, 444 there. And if I the count is showing cutting, yeah, count is 444. Okay, now even if I will open the previous what happened to these cases in previous files. So I will just open that Excel sheet, and just we will check that last time. This is the I column. What happened to them in last? So let's check here also. So I will just previous, and we'll just check. Just wait and watch. Don't angry on me. I'm just okay. So we'll get the values. One zero is for not churn, one is for churn. So what happened to them previously? Oh my god, you can see here, they will all churn. As I told in last video also. But what here is stacking is doing the giving us the more numbers, and the 444 cases that the you know stacking has predicted that it will churn, and lastly these cases will also have the same result. So this is the major thing, and what a beautiful if you can understand now, stacking has given us, from I told you the cases were 480 something and 444 cases they have given. So we don't have to bother about the low report because majority chunk has come in this report only, in the high report, and if we go to the low report, then they will have mixed values. So basically the thing was that our automation that we want to do is for the majority of the cases that comes under more than 90. So okay. So this is a very very correct automation. Now we will go to low. You can see only 44 cases are there. Okay, so even we don't have to, because we don't have to bother for what, because our priority is for this only. So what happened is, triple four air in high, uh, that have the highest probability of more than 90%. So wow, so this stacking model is uh, doing absolute predictions for the new data, and for this particular revision problem of customer churn, it has given maximum results. So guys, this is Akhil Singh Rawat. I have already given a very very easy and effective presentation of this cloud and supervised machine learning based customer churn analytics, and I have already show you the effectiveness and benefits of cloud. So now I am signing off. Please take care of yourself and have fun, and take care. Bye bye.